A very good afternoon, everyone. I, Dakshi Agarwal, on behalf of UPES-CSI Student Chapter, welcomes you all to this workshop on machine learning. UPES-CSI, in collaboration with Reskill, presents a workshop on machine learning. Machine learning is the study of computer algorithms that can improve themselves automatically on experience and data. It is regarded as a component of artificial intelligence. It is widely used in business and industrial problems as well as much more than one might expect. So, before starting, it gives me an immense pleasure to welcome and introduce our honorable guest and speaker of this workshop, Ms. Princey, instructor and product engineer at Coding Blocks. Princey is a postgraduate from IIIT Delhi and did her graduation from NSIT Delhi. She joined Coding Blocks due to her passion for teaching. She has a prior experience as a software engineer and has done research in the field of computational biology. Her interests include machine learning, data science, and game development. She's a Pythonista and likes to draw and watch anime for fun. Also, I would like to take this opportunity to welcome our beloved attendees who have joined us. We accept your healthy participation to the workshop. Well, now it is the time to hear your words, ma'am. I would kindly request you to start the workshop.
Yeah, thank you, Dakshi. My screen is visible, right?
Yes, ma'am.
Okay, okay, cool. Uh, yeah, first of all, I want to thank all of you, like for having me for this workshop. Um, Now, moving on with the agenda for this workshop, I'm going to start with the machine learning applications, like where in the real world we see machine make like how people are using machine learning to improve their services and give a better experience to users. We're gonna take a look at that, the applications, and through those applications, I will try to uh, you know mm, convey like what we will try to understand what machine learning is, right? And we will also look into the basic terminologies which are frequently used whenever uh, you talk about machine learning. And after that, we will try to understand this machine learning algorithm, which is k nearest neighbor, how it works, by building our own classifier, which is pug and German shepherd classifier, right? And then there is this hands-on application, because I mean, just learning the theory is not enough. We also need to have some hands-on experience. So we are going to do this mini project, which is digit recognition using k nearest neighbor, right? So moving on to the applications part. So machine learning is everywhere. Starting with your own, if you're using a Gmail application or any messaging service for that matter, so you see that there is kind of filtering happening, right? Some of your mails, they get transferred to your spam box, and some of them they get transferred in your inbox, right? So you see this kind of email filtering. So yeah, this is an example of machine learning. What Google, if I talk about Gmail, so what Google has done, it has trained some kind of model, or I would say machine, a system, which is able to perform this kind of filtering for you, right? Then we have object recognition. Object recognition means we basically want to recognize the objects. So as humans, right, we humans recognize objects all around us all the time, right? This is so easy for us. But what if I want to design a system, right? We want some machine to do that similar task. So how that machine is going to recognize those objects for me, right? So For example, the application of object recognition that we see is if all of you are using Google Lens, you can see that you can do this product image search on Google Lens. For example, let's say you want to, you may have some shoes and you click this photo and, you want to see the related images with respect to that, whatever image you captured, right? So you can see that Google Lens is able to recognize the shoe which you have captured, or maybe yeah, in your in that image, the object which is there in the image, it is able to recognize it, and it is also able to show you the relevant images corresponding, right? uh, Similarly, let's say, maybe you clicked some image of, let's say, a banana tree, right? And you just so Google Lens is able to show you the relevant information about that banana tree, and maybe, some Wikipedia link. Okay, this is um, and all the relevant information. So what you see here is my model, whatever system I have, there is some system which is able to recognize, which is able to identify what is the object that we have captured in a particular image. It could be an Elmira, it could be, some laptop, it could be anything, for that matter, right? But my system, I have trained some system which knows, okay, what maybe a banana tree looks like, what a shoe looks like, right? What all, and it is able to show me the relevant and similar kinds of images also, right? Then we have video surveillance of traffics. So if like some of you have been in Delhi, so you might have seen that, the government has installed cameras on the roads, right, for the surveillance of the traffic. And if I don't know if some of you have experienced, and if there is, if any vehicle, there is some kind of, violation of the traffic rule, maybe, maybe you jumped some red light, or maybe you park your vehicle in a non-parking area, right? So what they do is they are able to recognize the uh, we have this so what is government doing? So through these cameras, they are, capturing, they have this continuous stream of your vehicle, right? On that vehicle, they have your number plate, right? So on the number plate, we what it tries to do, there is some system which tries to recognize the numbers on that plate, right? Once the numbers have been recognized, they can map the vehicle with the owner of the vehicle, right? And if there is some traffic violation, rule violation, they send the e-challan onto their IDs, right? So this is again, we are trying to recognize the numbers. So this particularly comes in OCR, which is character recognition, but optical character recognition, right? So uh, yeah, again, so this kind of object recognition, this is again an application of machine learning. Then we have Google Photos. Google Photos, all of us have been using Google Photos to back up our images, right? And whenever you use it, you might have seen, Google Photos is able to, club together, or I would say group together, similar kind of photos. And if you're using it, you must be seeing, it has made these sections, right? So if you open your Google Photos, let's say, you guys are in Dehradun, so maybe you went for some trekking trip, right? So let's say, it will label something like, all your mountain related images, right? So if you click on this, you will see, then it will list down all the, mountain pictures in under that section, right? Similarly, it also shows you some different people. So let's say this is your mother, this is your maybe brother, or some friend, all that Google Photos had, right? So similar kind of photos. So all of those photos in which we have, you have your friend, they are basically clustered together. So you can see that, you know Google Photos is, there is some, system, there is some model, I would say, that is able to recognize the similar kind of images and doing this clustering part thing for me, right? Grouping the same pictures together. So this is again, an example of machine learning. Then we have another application, which is smart lock, right? In our phones, we have like we in these days, everyone has a smartphone, and you are able to unlock it using, maybe using a face lock, or maybe using, your fingerprint or thumbprint scan, right? So In this kind of application, what is there that whenever there is a new fingerprint scan or a face scan, what my there is a system, or I would say a software inside my phone, which is, tries to match, okay, this new incoming fingerprint scan, does it matches to that of the owner or not. So this is a one to one kind of identification, that whether this new fingerprint scan, it belongs to user or not. We want to predict that, right? So this is an again, a application of machine learning. Then in the health sector, healthcare sector also, machine learning is being used for, maybe to uh, to do the survival analysis of patients. So let's say, you know uh, there is some hospital, and hospital has been collecting data about its patients for years after years, right? And now that they have this huge amount of data of patients, they want to use this data to, somehow predict the, what is the survival, I would say, whether a particular patient is going to survive after a particular treatment or not. So let's say maybe, you have cancer data about the patients, right? Whether, and we want to predict whether a particular the cancer treatment, whether it is going to work on a particular patient or not. And that the treatment of cancer is really costly, and when not that it is just costly, it is also very painful. So and so whenever someone goes to this treatment, so first of all, not everyone can afford it, and if someone is able to afford it, maybe, at hand we want to maybe have some kind of, a survival analysis. Okay, if we give this patient this particular treatment, what is this patient gonna survive or not, right? So yeah, I mean, this is how machine learning answers these questions or do these kinds of analysis, right? And another application is, tumor identification from the x-ray and mri images. So we have the x-ray images. So earlier we used to have doctors who would, take a look at this x-ray image, and they will try to predict, okay, whether this particular patient has, whether there is a tumor or not. Now the same thing, we want some software, a piece of software, some kind of model to do, right? That if I show that particular system my, x-ray image, then it should be able to tell, okay, whether there is a tumor in that image or not, right? Then personalized medicines. So personalized, what are personalized medicines means that, you must have experienced this, around you, or maybe on yourself, in your lives basically, that, some kind of medicines, they work on some people, right? On some maybe it works on some a few people or on someone very nicely, but it may not work in the similar manner in some other person, or say some person x, right? So this is what, this is where the concept of personalized medicines comes into picture, that biologically each of us are different from each other, right? So my I would say, that my genomics is different, my composition is different from, some other person, or any of the person. We may be similar, but we are not identical, right? We have our differences, and we are unique in ourselves. So what medicine might work on me, it may not work on you, or what is working on you, it may not work on me, right? So this is where, we somehow want to use the data about, the patients, the people, their genomics data, to, to give out, or to come up with personalized medicine, a kind of prescription, which definitely is going to work for me according to my let's say body composition or genes, whatever genomics I have, right? So this is again, where, these medical researchers are trying to use personal, machine learning to uh, to move, to make movement in this domain, which is personalized medicine. Then we have speech recognitions. You all must have seen, and some of you might also have, Alexa, Siri, or Google Assistant, all these personal assistants. What what they are doing, right? They are correctly able to recognize. Speech recognition means recognizing the speech, what are the words spoken in a particular speech. So these personal digital assistants, they are able to, so what are these? They are basically a software, right? There is some software which is able to recognize what I am speaking correctly, right? So how it is doing that? So there is some system which has been trained a lot of speech data, that how, maybe if I'm speaking how, then how sounds like this is the data. This is, whenever someone says how, this is how it sounds like, right? So it has been trained on such data for a long time, and now whenever it listens to that particular thing again, it is correctly able to recognize it, right? So this is speech recognition. Speech recognition is also now used in voice activated bankings. You must have seen the you know in the banking sector, they want to improve their services. So earlier they might be, they might be assigning some person X, okay, you are, this is your manager, and just talk to him whenever you have your query. But now they want to have this, bot, chat bot kind of a software, and you can just send your query to that bot, and it will try to resolve it, right? So voice activated chat bot, it can be a chat bot, and it can also be a, a bot which is some kind of voice, right, which is able to recognize, okay, you are saying this, you are saying that, and accordingly come up with a smart response. That if I have a credit card related query, then it is also, giving me a relevant response. Okay, I will keep you in, maybe, get in touch with the relevant person in the bank, something like that. Then we have business analytics. Now that businesses, we have this digitization and this boom in the digital information, everyone is using, smartphones, and they are trying to upload their data onto web, right? So it is publicly available. And so all of the businesses, they want to somehow use this data to improve their services, to give customers a better experience, and if there are some challenges, they want to solve it using the data they have, right? So if I talk about churn prediction, so some of you might be using Netflix, these subscription based services, so like Netflix, YouTube Premium, or Amazon Prime, all of these, right? So for these businesses, to improve, I would say, to earn a revenue, it is very important for them to keep their customers, right? So they want to predict whether some person, the customer is going to buy the subscription next month or not. So this is churn prediction. Like, given the data, let's say if I am a user of Netflix, I watch a lot of maybe movies. So given my history, given my watch history, given the time I spend on Netflix, so they want to predict, okay, so am I gonna buy the subscription, Netflix subscription, next month or not, right? Similarly, you have, Medium. There is I hope everyone uses Medium. So they publish really good articles, and almost about any topic. It is food, health, software, technology, whatever, right? It is again Medium is also subscription based services. So based on the reading history of a person, we want to predict whether the customer is going to buy the subscription or not, right? Because for these businesses to run, it is important to retain the customer. So as long as the customer keeps on using the service, as long as they are engaged, they are going to earn money through them, right? Then we have detection, fraud detection, right? Based on the the history, or the details of a transaction, we want to predict whether that transaction is fraudulent or not. So here again, we want to make some model recognize, given some data, we want some model to recognize, okay, this transaction is fraudulent. Then we have recommendation systems. Recommendation system, you must have seen almost everywhere. If you are, let's say, an Amazon user, you must have seen, this kind of recommendation. People like you have bought this, or customers like you have bought, these products, right? And so there are, you see, mostly see two kinds of recommendation. First is based on, people like you, like they're first, they have some system which tries to recognize the similarity between users. So let's say if I am, I have some taste, right? uh, let's say I like to watch maybe sci-fi movies, right? and there is some my friend which is and I have watched, let's say, Star Trek. Okay, then there is some my friend, and also has a similar kind of taste, means he also enjoys uh, you know sci-fi movies. Then Netflix tries to, and that person, be that my that friend, has watched maybe Star Wars. So based on the similarity, that we have a similar taste, Netflix might try to, you know, uh, tell me ki, okay, people like you, so it might recommend Star Wars based on that, so based on the similarity between two users, right? So data of customers is being used to make these kind of recommendation, to find the similarity between two people, and to find similarity between two objects also, right? So maybe, you buy a lot of books maybe on Amazon, then it might recommend you maybe, okay, uh, similar recommendations ki, okay, people have also bought this, this is another book which you might like. So object similarity between the orders, or the products, or similarity between the users. So it is somehow used to make recommendation to people. And so we have recommendation systems, some piece of software which is doing it, providing us these relevant recommendation. On Amazon, on Netflix, they recommend movies. On Medium, they recommend articles based on our reading history. So you see that somehow, one way or the other, our data, customers data, is being utilized, right? And there is a model which is learning from this data and making relevant recommendations. Then we have automatic picture taking using hand gesture recognition, right? These days you must have seen in the cell phones, you need not push the button to click the picture. You can simply make some sort of hand gesture, and the cam which triggers the camera to click your picture in some, maybe after some time, right? So there is some system which is, correctly able to recognize whatever gesture you have decide for clicking the photo. And yeah, I mean, that's how. And whenever it sees that kind of gesture, mm, the photo is clicked. Then we have self-driving cars. So in these self-driving cars, it has to continuously make decisions, when to stop. If there is a red light, it should stop. If there is a vehicle ahead, it should stop. And if there is which uh, what turn it should take. So in making all of these decisions, so there is a continuous stream of the road, right? And based on that input stream, there is some system inside my self-driving car which is trained to recognize and whether there is a red light or not. And if there is a red light, then the car should stop. If there's a green light, it should start moving. If there is a vehicle ahead, it should stop. Also to make all of these decisions, right? Then we have biometric machines. So or biometric machine. So for example, you must have seen in your colleges there is this machine which is installed to mark the attendance of your maybe the professors, right? So yeah, I mean, earlier we used to have this, a lot of proxy used to we used to have a lot of proxies, like the employee won't even go to the college, but still we will have some person other person will just mark their attendance. So for this kind of verification, to this was a problem, and to solve it they came up with biometric verification, right? So in that, first of all, what they do, let's say there is an organization, and let's say 50 people work in that organization. First of all, they collect the fingerprint scan of all of these people. And whenever there is a new fingerprint scan, that new fingerprint scan is matched with the whatever images we have in the database. So this kind of recognition, one to one, one to many, we want to match that, whether this new fingerprint scan, it matches to that of person A, B, C, D, or whatever person. And then based on the the highest similarity, we give out, okay, this fingerprint scan matches the most with person B's fingerprint, and uska fir they can mark the attendance. Then we are also using weather forecasting data about given some weather conditions, let's say the wind pressure, or um, how's the temperature, to make to forecast the weather, right? So weather forecasting is used, let's say if there is going to be some natural calamity. So predicting the weather, the weather condition ahead of the time, it helps, maybe to move people if there is, let's say, going to be some flood. So we can evacuate the area in the meantime, right? Reducing uh, the number of people, getting affected by that, right? So you can see that machine learning is really on, we now are using all of this data uh, to really help people, to give them a better experience, to improve their lives. And because of this digitization, storing information digitally, this has given us power, and to generate a lot of data. And since we are generating a lot of data, we now want systems, we now want uh, to make use, we want to utilize this information that we have, right? So that is where, this machine learning comes into picture. So through these examples, if you try to understand, you can see a very critical, one thing which you can find common in all of these is, having data is very critical in all of these applications. For example, email filtering. First of all, if you want to build some model to, you know um, which is doing, model as in software, there's some piece of software and it is doing this email filtering task for you. So we want, first of all, that particular system, it has been shown emails which are spam and which are not spam, right? Just like we as humans learn. So if I want to teach, my a little kid ki, okay, this is the image of a cat, this is an image of a dog, then first I'm going to show that kid a lot of pictures of, a dog. Ki, okay, this is how a dog looks like. A new picture of dog, again some dog, showing the kid a lot of dog images, showing the kid a lot of cat images. So once the kid has seen enough amount of images of dog and cat, whenever there is a new picture, the kid is able to recognize, okay, this matches with that of a dog, right? Similarly, showing data. So showing pictures, we as humans receive information through our sense organs, right? Eyes, nose, skin, taste, right? All of these are, helping us receive information, right? uh, Similarly, we somehow, need to, we are building algorithms, we are building a software to which we are giving them some input, and they are doing, this kind of categorization for us. So I showed a system an email, and once I have shown enough amount of emails to this particular system, now this system understands, okay, this is how a spam mails look like, mail look like, and this is how an, a not spam mail looks, ham mail looks like, right? And whenever there is a new email, it is able to correctly, filter it. So similarly for object recognition, first of all, a lot of images have been, the system has been shown a lot of images about each of the object. If it is an almirah, then the system must have gone through, thousands and ten thousands of images of almirah to understand, okay, this is how an almirah looks like, this is how a banana tree looks like, right? And then only after training for so long, after seeing so many images, a lot of images, now whenever there is a new image, my system understands, okay, this is, my system is able to maybe group similar pictures together, and classify them into, categories. Okay, this is a mountain, like pictures, these are, some person X, right? So all of these identification, it is able to make it. So the common thing in all of these applications is the data, right? And so if we try to understand what is machine learning, so in simple terms, and in this workshop, we are only like, learning can be of multiple types, but in this workshop we are going to talk about supervised learning mainly. Supervised means uh, telling the, actually telling ki, okay, as I told you, right? How the learning is supervised. Whenever we say supervised means, there is some kind of supervision on the learning, so that whenever a model is making a mistake, model means, let's say, you know imagine you have a test, right? You have a test, maths test, okay, and you are preparing for the test, and you have been solving, maybe questions, and there is some supervisor. Whenever you make a mistake in your test, so in your test, or I would say, you are undergoing a lot of mock test, okay, so in that mock test, whenever there is a, mistake performed by you, then there is some supervisor or your tutor who is there to supervise you, right? Who is there to correct you. Okay, this is wrong, this is right, this is wrong, this is right. Okay, so based on this supervision, we my model, who is the model in this case? I am the model, or whoever is taking the test, the person, and that is the model, right? So I am being supervised to, so as to perform good in the maths test. Okay. Similarly, I told you, the way we were teaching the kid, or maybe young brother, okay, this is a cat, this is a dog. So we are first telling him, this is how a dog looks like, this is how a cat looks like, right? So this is this kind of whenever in the learning process, when there is a, this kind of supervision, in which supervision means we actually are telling key, whatever thing you want to predict, or you are basically telling, okay, that, let's say, if this is image classification, cat versus dog, so you first show the system images of cats, you first show the system images of dog, right? So that is your supervised learning. Okay. So so yeah, I mean, in this workshop, our discussion is going to be around supervised learning only. So what is machine learning in layman terms? Making prediction on unseen data based on the previous data. Previous data means, as in the healthcare, or maybe in some hospital, or the hospital is collecting data of the people, of the patients visiting the hospital for x number of years. So all of that previous data is now used to make prediction on the new data. Okay. So maybe so for example, if I take example of tumor identification, a lot of x-ray images have been there of, in which we have a tumor, in which we do not have a tumor, of both categories. And based on these, looking at, we have some previous data, and now whenever there is a new x-ray image, let's say a new patient comes to me for x-ray, and we want to tell whether that guy has a tumor or not. So now we want to utilize this previous data to make prediction on this new x-ray scan. Okay. So this is what machine learning is. So similarly, in case of email filtering, there have been some previous data. What are the previous data? All of the emails which, which have already there in the system, already there, already there. And whenever there is a a generation of a new email, we want to categorize it into two, whether it is a spam or not spam, right? So we want to make this kind of prediction. So, in layman terms, making prediction on unseen. Unseen means new, or something that I have never seen. My model has never seen before, right? Just think of your maths test. So, in the maths, in case of a maths test, you have you have solved a lot of problems for your maths book. So that is the training phase, right? And in the test, you might have, then you have new kind of questions, different questions. They are similar to what you have learned from the book, yes, and based on the knowledge you have learned from, by practicing, or in your training, you want to basically apply that onto the unseen questions, right? Similarly, so yeah, this is your this is what machine learning is. Then this kind of prediction that we are making, so if I have some image, so let's say I have an image, and whenever I have a system, as in you can call it model or a piece of software basically. So whenever I feed this system an image, uh, I want, let's say, I want to build some kind of classifier which distinguishes between cat and dog. So this kind of prediction, right? So my system tells, okay, this is a cat. My system tells, okay, this is a dog. So this output of my model, the model's output, it is known as the, predicted variable. It is also known as the label. Okay. New data, this past data means the previous data on which the machine learns, that is known as the training data. And the new data which has never been seen by the machine at all, that is known as your test data, right? And another thing is, data has features. Data has features means, so what are features? Features are, whenever say, um, okay, let's try to build this classifier. Let's say my aim is to build a pug or German Shepherd classifier. German Shepherd classifier, right? So if I have to build this kind of model, so what I need to do first of all, so to solve any problem, first of all, what I need to do, I need to have some kind of data, right? I need to collect data about the dogs, right? So what I want to do, let's say, okay, now what is this data? This data has to be about dogs, obviously, right? Because what is, always keep in mind the problem you are trying to solve using machine learning, and you need to collect the relevant data which will help you. Since I want to build a pug or a German Shepherd classifier, so can you tell me, let's say in my street I have 20 dogs, all right? In my street I have 20 dogs, and let's say all those 20 dogs, they are either, let's say 10 are pugs and 10 are German Shepherd. All right. So what I do is I measure, or maybe I record, I just one by one go to these, maybe get to these dogs, and somehow record some data, record their features. Okay, features or attributes or characteristics about these dogs, which will help me to make the classification between pug and German Shepherd, right? Very important. So can you tell me, like, what are those features which will help me? What are those features? What are the things, or what are the attributes about the dogs which you might want to record, which will help you with this classification? Can I see the chat box? Okay. Anyways, so I hope you are able to, like, you must have thought of something. So we want to collect data about the dogs. So the data could be, let's say I want to record the height of the dog, I want to record, let's say, the weight, right? And some of you might think, okay, the fur is also different on a pug, right? So maybe the fur type, whether it is long or it is short, something like that. Some of you might say, okay, color could be, we can also record the color, right? And so on. I mean, maybe, maybe the type of face, the shape of the face, right? Whether it is round or elongated, something like that, shape of the face. So that is another features. So I hope you got the idea about the features. What are features? They are basically characteristic about the entity, right? The attributes. And what are the entities? These, the pug and German Shepherd, for example, it is an entity. So let's say these are, and you can obviously record much more features, many more features, but remember that, okay, some of you might say, okay, I can also, maybe I want to record whether, that particular dog, it is angry, or maybe is it loyal or not. Maybe have, whether my dog has this feature, loyalty or not, right? So remember that in your data you always want to have the concrete features. So as you know that loyalty is, or the loyalty of a dog is not something which is concrete, or I would say, which you can measure precisely, like, right? So don't have, these difficult to measure features. Never have those, right? The things which you cannot measure correctly, don't have them, right? So good features are those which are concrete, okay, and which you can quantify easily, right? So you can see that height can be measured, weight and fur type as in, whether it is short or long, something like that. Then you have color, then you have shape of the face, whether it is, a long or elongated face, or maybe some round kind of a thing, okay. So you know you have 20 streets and dogs in your street, and you measure and you record all of these information about these 20 dogs, okay. Apart from these features, you are also, keeping track of the breed of the dog, whether the dog is pug or a German shepherd. We are also recording that within our, table, right? So I took, I get to dog D1. I measured, his height was H1, the weight was W1, fur type, I don't know, let's say short, color, some color C1. Then we have shape, maybe, I don't know, round. And loyal, there is no loyalty. Bad feature. Loyalty is not a very good feature to have. So just let's get rid of that, right? And let's say this particular dog was pug, okay. Similarly, I record all of these features for each of the 20 dogs, right? So dog D2 was H2, height, W2, weight, let's say, fur was, let's say, again, maybe long this time. Then color was, let's say, C2, and shape was elongated, and this was a German shepherd, right? And you did it for all the 20 dogs, right? So the 20th dog will have some height, H20, W20, weight, right? And so on, right? So in this table you can see how many, if I ask you what is the shape of your, or what is the size of your data, this is your data, this particular table, this is exactly your data, right? So so remember that, what are features? Features are the things based on which you want to make prediction. So in your data you can see that what is the thing that you want to predict. The thing you want to predict is the breed. So this is known as your label. The whatever value you want to predict, the thing you want to predict, it is known as the label. The values or the data which you are going to use to make prediction, they are your features, right? So these are your features, okay. These columns. Features means attributes. So like some people might argue, okay, breed could is also an attribute. Yes, but is it the thing, is it something that I want to predict? Since it is I want what I want to predict, that is why it is my label. Similarly, let's say instead of, predicting the breed of the dog, let's say I wanted to predict the weight of the dog, let's say, right? Then in that case, weight would have been my label, and rest of the, columns in my data, let's say height, fur type, color, shape of face, and my breed, all these would have acted like my features, okay. So as you can see that, in your data, the number of columns, they are, kind of just treat the thing that you want to predict, or the label separately, treat it separately. So you can see the number of columns, they are basically representing your features, number of features. So in this case, 1 2 3 4 5, let's say I have 5 columns, and the number of rows in my data, just imagine it in form of a matrix which has rows and columns. So rows, in the rows we have what? We have our samples. So these rows, they are known as samples. You might also hear the word entity. You may also hear data point. All of these are the same, people use them for the samples, right? So the rows, they basically represent the number of samples, and we have the sample information, and the columns, they basically represent the features, right? So we have, if I talk about what is the size of my training data, and I'm calling this as my training data because on this data I'm going to, train my machine. I'm going to use this data to make prediction, right? So I'm going to call this as, this data that I collected, this is my training data, right? So this is my number of rows is number of samples, and the number of columns, which is 5 in this case, this represent the number of features. And if I ask you, so training data means, I would say, training data ke only the features. So in so in machine learning, your features, right? So if I, call or maybe represent this data, this feature, think of a matrix. I want to represent these values in form of a matrix, right? So that particular matrix I'm representing using X. So the a convention to represent the feature matrix is we represented using X. Similarly, your label is represented using Y. Okay, and since here we have the features of this particular matrix, this is representing the features of my training data. So a convention which you might seen a lot is, X train. X train means feature of my training data. Similarly, you might see Y train. Y train means labels of my training data. Okay, similarly, after this, once you have collected this, so let's say, just for ease or of understanding, we are that instead of these 5 features, we just have height and weight with us, right? That what we want to do is, now that I have collected, the data about these 20 dogs, what I want to build a model to which, if I show the characteristic of the dog, meaning if I show this model the characteristic of a new dog, entirely new dog, whose characteristic I measured, let's say its height was H, weight was W, fur type is some fur, I don't know, color C, and shape of face, some face shape S. Okay, if I give the values, these features to my, if I feed these features to my model or whatever software I have written, it should be able to make the prediction, whether this information, whether this characteristics, these feature correspond to a pug, or they correspond to a German shepherd. This is what I want to do. And remember that this thing, they are unseen. Unseen means totally new examples. Okay, we also call our samples examples. Unseen examples means unseen data. My system has never seen these values before. Okay, so we want, this is what making prediction is called, making prediction or inference, this phase, or inference. Okay, so yeah, I mean, just for the ease of, since through this example we want to understand our KNN algorithm, and things are easy for, if when we have, let's say, let's restrict ourselves just for the sake of simplicity to 2 features. So let's say I am only using height. Let's say I'm only using the height and, yeah, I mean, just, why this is getting selected. Yeah. So I'm saying that for the sake of simplicity, we are going to work. क्या हो गया इसमें? So we're just going to work with the height and weight of the dog. Okay. Just a minute, guys. I don't know what's the problem. Yeah. So to visualize things properly, we are going to have just two features in my data, which is height and weight. Yeah. Okay. So in my data, just imagine that instead I have a matrix. Matrix means my table, it only comprises of two columns, height and weight, in which I have D1, D2, D3, and D20. So this is my training data, and corresponding to these the height and weight, I also have my labels, which is the breed. Okay, so this is my white train. So since now we have only two columns with this, so the size or the shape of my training X train, it is going to be 20 comma 2, in which 20 is my number of samples or number of examples, and 2 is my number of features in each dog, right? So after this, once we have collected that H1 W1 H2 W2 corresponding to these 20 dogs, let's say what we do is we visualize this data. Visualize means we basically plot this, these coordinates that we have on a graph. So let's say I plot my, weight on the x-axis and the height of the dogs on the y-axis. Okay. So when I plot these, and just treat h1, so one coordinate on this or one point on this graph, it basically has two coordinates, right? So this is my h1 and this is my w. Oh, sorry, this is my h1 and this is w1. This is my h1, this is my w1. Then I picked the second coordinate, which is h2 w2. I plot this on my, so let's say this point is here. So the corresponding value on the x represents w2, and on my y axis it represents h2, right? And similarly I plot all of my points, all of my 20 points. So let's say these are my points. Okay, these are my 10 points, and similarly I have these 10 points. Okay, all right. So now what I want to do is, so first of all, does this graph make sense? So in my data, since, can I say that all of the pugs, since they are smaller in height and weight as compared to my German Shepherd, so these green dots, they basically represent my group of pugs, right? Can I say that this is going to be my pugs? Similarly, since my yellow dots, you can see the height and weight, whatever weight this is, w dash, or whatever height this is, right, h dash. So you can see the yellow dots, they are they may be representing my German shepherds, right? So this group, it might be representing my German shepherds because their height and weight is larger as compared to the pugs, right? So what I want to do is, whenever there is a, now I have some unseen dogs attributes. Unseen dogs means they do not belong to these 20 dogs. I went to some other street. I found a new dog, let's say a pug or a German Shepherd. What I did, I basically recorded its height and weight. So let's say I had some dog D1, D2, D3, and D4, right? And I recorded their height to be, let's say, H1, W1. Then we have H2, W2. Then we have H3, W3. These are my new dogs entirely. Like my system has never seen them before, right? H4W4. Now, what I want to do, I want to feed these new, the features of, these new dogs. So I want to show my model H1W1, and my model should be able to predict whether this H1W1, it represents a pug or whether it represents a German Shepherd, right? This is my, then I say that, okay, this model, this is performing this sort of classification. It is classifying between, you know, the pug and German Shepherd based on the height and weight. Okay. So let's say this H1W1, when I plot it on this graph, it comes, these coordinate, they correspond, when I plot it on the graph, it comes somewhere around here. Okay. So looking at this, can I say that, based, since this new dot, it is coming closer to this pug cluster. So can I say that, okay, so this might be, this particular dot, it might correspond to a pug because this new dot, it is coming closer to my, where my pugs are lying in the coordinate space. Similarly, let's say I had another, I also plot this dog D2, and when I, plotted its coordinates, so it came somewhere around here. So this is my H2, and this is my, sorry, this is W2, and this is the corresponding height, it is H2. So what, based on this, what can I say about the category, like given these features, height and weight, given this height and weight, what can I say about the category of the dog? So can I say that, I mean, this particular pink dot, it basically corresponds to a German Shepherd, like based on, since this dot, it lies closer to my German Shepherd group, right? Now let's say this dog D3, when I, plot it on my graph, it comes somewhere around here. Let's say somewhere around here. Okay. Again, based on the closeness, you might say, now you can see that, this particular dot, it is closer to my German Shepherd as well as my Pugs Wala group, right? So we are going to see, okay, to which group it is lying more closer. So you can see key that, okay, it is more closer to the Pugwala group. So again, you might say that, okay, this is a pug, right? So you can see, I mean, in this particular like what we are doing, you can see that we are making prediction in this particular example. We are making prediction based on the closeness of my new point with my training data point, right? So what we are doing, we are somehow trying to look at, we are somehow trying to, I would say, quantify the closeness between the new point and the rest of the points in my data. Okay. So this is exactly, in which this algorithm, which, tries to find the, uh, we try to make prediction based on, what, how does my neighbors look like. You can see that, let's say if I had some other new dog, let's say it lies somewhere around here. Okay. So what I will do, for any new data point, I'm going to see what are which dots, what I'm going to find, what are the nearest neighbors of this. Let me get rid of these extra colors, lines. Okay, so yeah, so let's say I had an entirely new data point, which is this. Okay, so what we do is that we try to find out the nearest neighbors or the nearest dots to my unseen this new data point. So let's say the nearest dots come out to be, this is my nearest dot, this is my nearest dot, and this is my nearest dot. Let's say, so out of three nearest neighbors, two of them are pugs, and one of them is German Shepherd. So what I'm going to say, that the category of this dog, it is going to be pug, because the majority says the closeness, this particular point, it is more closer to my pugs wala, right? More of the nearest neighbor, they are of pugs, right? So this particular algorithm, in which, based on the nearest neighbors, the major what is the category of the majority of nearest neighbors, we predict in the favor of the majority. So as you can see here, the majority says the category is pug, so therefore we say this unseen data point or the new data point, it has a category pug. Okay, so this particular algorithm, this is known as KNN. K means nearest neighbors. What is K here? So for example, in this case, I said that I am going to look at the three nearest neighbors. Then what is their category? I'm going to find the three nearest neighbors. Similarly, you can say we are going to find. I'm going to take a look at the five nearest neighbors in my data. Okay, so this is what K means. This is what is K. So in this example, we looked at 3, so K is equal to 3, right? And K is also known as the hyperparameter. Hyperparameter is something which the user or we as programmer decide. For example, I said I am going to look at the three nearest dogs. Similarly, some other programmer might say, okay, I'm going to look at the five nearest dogs, right? So this is something that we decide. Okay, so how do we make prediction using k nearest neighbor? We first of all compute the distance. So we somehow need to as I'm saying, since my, like we again and again said that which nearest neighbor, how are you going to find the nearest neighbors? So nearest neighbors are those whose distance is less from my, or they are closer to my data points. So how are you measuring this closeness? We are measuring it using the Euclidean distance, a very frequently used metric uh, for measuring the I would say the closeness, right? So distance is a very frequently used metric. So what we do is we compute the distance of the new data point or the test point from each point in training set, each point in training data, right? So let's say if this was my new data point, then I'm going to compute its distance from each of the 20 points, right? So I'm going to compute from every point in my data set. If I had 100 dogs in my data, then I'm going to compute the distance of this point with each of my 100 data points. So I'm going to have 100 distance values, right, from each point. Okay, then once we have, so corresponding to each dog, we are going to have a distance value. So d1 represents distance between dog d1 in my data, training data, and the new dog. D2 represents distance between dog d2 of my training data and the new dog. Similarly, d3 and d20, or I can say di. So di represents distance between ith dog in training data and the new dog or new test point. Just let's call it test, the test point. Okay, So once you have the distance with you, based on this distance, we are going to see, what are the closest neighbors, based on this distance value. So let's say you found out the smallest value. So if I want to find the closest neighbor, so can I say that I am basically looking for, those dogs whose distance value is very less, right? So let's say for this particular case, my k is equal to 3. So I'm going to find k nearest neighbors, or maybe 3 nearest neighbors in this case. To find these 3 nearest neighbors, what I can say is I'm basically going to get the, let's say, d2 had the d2 value is the least, then we have, let's say, d5, and let's say we have d20. Okay. Means the distance between, what does this mean? I mean to say is the distance between dog d2 and the new dog is the least. Then the second uh, minimum is my, distance between my fifth dog and the new dog. Then the 20th dog has the third least distance, third minimum distance with my new test point. Okay. So once we have, these numbers, what we do is we get, okay, then we ask these. Okay, we have identified the nearest neighbors. It is dog d2, it is dog d5, and dog d20. Now based on, right, now what we do is we ask them we have identified our nearest neighbors. Now we ask them their category. Okay, tell me your category. So let's say this dog d2 has a category pug, d5 is pug, and let's say d20 is also let's say pug. So in this case, what I'm going to say, I'm going to make prediction in favor of the majority. So I am going to say that the new dog D dash has a category or has a breed pug, because the majority of my nearest neighbors said that they are pug. Similarly, let's say instead of having this combination, we rather had, let's say this was pug, and let's say this was German Shepherd. Here also we would say that, okay, since again the majority of the dogs, out of three, two of the dogs are saying that they are pug, right? So again, we are going to make prediction pug. Let's say this time we had, this was German Shepherd, this was German Shepherd, and this was pug. So in this case, the majority is German Shepherd, right? Similarly, you could have German Shepherd, and German Shepherd. So here also you will be having the majority, right? So this is your KNN algorithm, guys. I hope it is clear to everyone, right? A very, common question which is asked for k is like, how to decide the value of this k, right? I'm not going into the details of it, but we generally keep, try to keep the value of k as odd. And why odd? Let me clarify this using this example. Let's say my k was, equal to 4. Let's say that I am looking at 4 nearest neighbors, right? So let's say there was some new dog d, and I found out that dog, uh, these were, the category of the 4 nearest neighbors was, let's say, pug, and all of them were pug. So here the majority is simply, pug. Similarly, if we had, 3 pugs and 1 German Shepherd, here again, we can favor the majority. So in even case, the problem is that, there are issues with tying, that we could have equal number of examples in my nearest neighbors of both the categories, meaning we could have 2 pugs and 2 German Shepherd. So in this case, what will you say the majority will be, right? Both of the classes, they have, equal frequency, that we have 2 neighbors corresponding to German Shepherd, 2 neighbors of pug, right? So yeah, I mean, in to just to avoid this kind of, ties or draws, I would say, between two categories, what we do is we take odd values uh, for k. We always choose k to be odd, right? So yeah, I mean, that was your algorithm. I hope it is clear to each one of you, right? So just a brief. So we talked about labels. Label is the value that we predict. Features, they are the input variables, right? And why we are calling them as input? Because this is something that we feed into our model, right? Or our model or our system, right? And they are represented using X. Then we have examples. We talked about examples, right? The samples in the data. So they are particular instance of a data. Instance means row, right? Instance or entity, right? And any so examples are of two kind: labeled examples and unlabeled examples. So for this particular case, since corresponding to my examples we also had the label, so these are known as labeled examples. Okay, so labeled examples are used to train the model. Similarly, unlabeled examples are your test data. Test data means we do not know the label corresponding to them, so they are unlabeled. Okay, yeah. Then we have a model. What is a model? It is basically, it maps the examples to the predicted labels. Meaning, what is a map? Map is basically, if I give, for example, think of it as a function, right? A function uh, in maths. So, what is a function? Let's say I have a function f is equal to x square, right? Or let's say if I have y is equal to f of x and it is equal to x square. So the input of this function is x and the output is x square. So this is the mapping, right? And it spits out y. This is what this function does, right? So it is mapping the input to this particular output. So if I give a 2 to my function, it will be mapped to 4. If I give 3, it will be mapped to 9. So it is a mapping. We are mapping the input with the output. So this is exactly what a model does. It maps the input. What are the input to my model? The features, the height, the weight, these are the input. And we somehow want to map it to my output, which is my label. The two phases, the training phase, right, in which the model learns, and the inference means we use it to make prediction. Then there are two, ML tasks, which is known as regression and classification. Classification means the output of my model is a discrete value, or it is it represents some kind of a category. So this, for example, this pug and German Shepherd, this is a classification example. And I told you, right? Let's say instead of predicting the breed, if we were predicting, let's say, the weight of my dog based on these rest of the features. So in this case, what we want is that my model, it should spit out weight, and weight is a continuous value, right? Continuous means we can have, uncountable. It has a continuous variable, it has an uncountable range, right? So for example, let's say in between 10 to 100 we have undefined, or uncountable, we can have infinite number of values, right? So this is a continuous variable. So whenever the output of my model is continuous, we call it as a regression model. And when the output of my model, it is discrete. Discrete means it can only take, finite possible values. So for example, in classification, in this particular pug in German Shepherd, my output, or the output of the model could only take two possible values. It could either be pug or it could either be German Shepherd. But in right, so this is a classification example. While in case of weight, since the weight could be anything, right? It could be, let's say 5.3 kgs, it could be 10.5 kgs, it could be 10.05 kgs. It has uncountable or infinite possible values for my dog, weight of the dog, right? So that is my continuous. So that is my regression model. So other examples are, what is the price of a house in Florida, or what is the probability that user will click on the ad. So probability, again, it is a value which varies from 0 to 1, a continuous value, right? Similarly, price of a house, let's say from as small as maybe $10,000 to, I don't know, 1 lakh dollars, something like that, right? So you can see it can be anything in between that range. So that is again a continuous value. Then we have classification. Classification ka example could be whether a email is spam or not, whether a particular image is of a dog, a cat, or a human, right? Then we made this pug or German Shepherd classifier. Then how KNN works? We compute the distance of my new data point, right? And mm, this is one such implementation if you want to sort it or not, right? If you want to sort the distance, or basically you need k minimum, the index of the k minimum. Basically have to get the nearest neighbors, and it's up to you whatever algorithm you use to get to it, right? Then we get the category of my nearest neighbors, and we make prediction in favor of the majority, right? So now, let's move on to the hands-on, which is, we want to make a digit recognition model, right? So digit recognition means we will be showing our model the images of these 0, 1, 2, 3, 4, these handwritten digits, which are going from 0 to 9. So, and based on, so what we have is, we have images of these digits, right? So, and remember that each image has only one digit, so either it is of 0, either it is of 1. So what I'm feeding to my model, it is an image, and this is my model. Similarly, and so on, you have up till 9. Okay, so these are my images. So if I feed my model in image of 1, then the output of my model should be 1. If the image is of 9, then output of my model should be 9. If the image is of 0, the output of my model should be 0. So this is again a classification problem in which my label is again discrete. It is only taking finite possible values, right? It can go from it can either be 0, it can either be 1, or 2, and up until 9. So it can only take 9, it has 9 possible values which my output can take, right? So this is again a classification problem. So I won't be so in my image, just like for my dog, and in our dog case, the features were the height, weight, and all of these features, they acted as my feature. In case of an image, the pixels are my features, right? So how an image is stored digitally. So let's say this is a, let's say the size of the image is 28 cross 28, right? 28 cross 28 means the height and width is 28 comma 28, and it also means that you can divide your image into a grid of 28 cross 28, right? So it can have 28 rows and 28 columns, and each of the cell, or each of the value in a particular cell, this is known as a pixel. Pixel means, it represents the intensity of the color, right? So generally a colored image has three channels. So it has a channel corresponding to red, it has a channel corresponding to green, and it has a channel corresponding to blue. So red, green, blue, as you know that all of the colors in this world, they can be formed using the various, or different intensity of RGB. So for example, if I show you uh, RGB color. So let's say R is for red, G is for green, and B is for blue. So let's say I the intensity, and it can intensity means it can vary from 0 to 25, right? You can have 256 possible values, and 255 is the maximum intensity, 0 is the minimum. So if I am, having the 0 intensity of all of my colors, like 0 intensity of blue, 0 intensity of green, 0 intensity of red. So if what is this color, what are these values correspond to? They correspond to black color. Similarly, if I have full intensity of all of my colors, 255, 255, 255, then we get the color white. And let's say we, increase a particular intensity. Let's say I have 255 for red and rest of are 0. Then we have a red color, right? And let's say then I want to mix up values. You can also mix up. Let's say I increase my intensity of blue. So you can see I got some, pinkish shade, right? So all of the colors around you, they can be formed by, mixing various intensity of my red, green, blue color. And when images are stored digitally, so let's say I have an image, I have a colored image, and in this particular, let's say this is an image of, a scenery. This is a scenery wherein here we have a brown color and this particular portion is blue in color. Okay, this is blue. And let's say the size of this image is 28 cross 28. Okay, so how will this image be stored digitally? So as you know, everything is stored if you want to store it, it has to be converted into a binary or in some number form, right? So you can break your image in three channels. And since in this portion, since you have a blue, right? So what you will observe that you can break each of these channels into 28 comma 28 grid, or a kind of a matrix, right? So this is green and this is your red, right? So red, green, and this is your blue. Okay, so since in this particular area you are observing a blue color, so what I can imagine is in the top corner of my arrays, here I will have a pixel value, let's say, which is equal to 255. In this green color array, I will have a value which is less, a less intensity of green, right? So let's say maybe 10. And similarly in my red, it is again, we will be having a low intensity, so let's say maybe 50, something like that, right? So when you merge these three values, so this 255, 10 and 50, this corresponds to a blue color. Okay, in which this is blue, this is green, this is red, right? uh, yeah, so this is how images are stored. So let's just move on to open our Jupyter notebooks. Okay, so this is Google Collab. This is not Jupyter notebook. So you guys can also open it like this. You all of you must be having a Gmail account. So just do a quick Google Collab search and click on the top link, and just click on this new notebook. As soon as you click on new notebook, you will be shown an interface like this, right? So herein we can type our Python code. So Google Colab is a service which is provided. It is basically, think of it as your virtual machine, and it provides you all of the requisite all of the requisite softwares and packages which are required to do machine learning, they are already installed on Google servers. All you need to do is you need to have a perfect a Wi-Fi to connect to the Google servers, and you can use their machine to perform their computational power, their memory, or the space they provide, to do your task, right? So just connect, and herein, we can type our Python code. So Python is the most common language to perform machine learning or any ML related task, right? So we are going to be using that. So the first thing, the packages which we are going to use. So let's import them. So import libraries, right? So these are known as your cells. Let me increase the size. So this is a code cell. Code cell means in here you can type your code, right? So to import the packages, the packages that we are going to use is import numpy as np. Uh, numpy is for numerical computation, so or scientific computing. Then we have import um, matplotlib dot pyplot as pld. Then we are also going to be needing, so this KNN algorithm, it is already pre-written for us, and we can simply use it in our code. So it is we already have you know developers have already made this API, which is sklearn. Sklearn. If you want to do any machine learning related task, then you can use this package. It basically gives you the utilities, and it is an API for all of your basically all of the machine learning algorithms. They are implemented in this package, and you can just use them. So from sklearn, the KNN algorithm, it is written in the it is present in the neighbors module. From sklearn.neighbors, we want to import a neighbor classifier, right? So this is the name of our these are the packages that we are going to use. Okay. So once you have imported them, the first thing, and again, we also need to collect the data, right? So the data, this handwritten digits data, right? As I told, we are going to be building a uh, digit classifier, digit recognizer, right? So we need to have this 0, 1, 2 images. We need to grab them from somewhere. So they can be made available from another API, which is yeah, Keras. So from Keras dot datasets, import. I think it's load mnest, or maybe it's just mnest. Yeah, right. Mnest means is the name of this datasets, this handwritten digit datasets. So to get, first of all, we need to get the data, right. We need to have the data with us. So to load the data, we can use the function mnest dot load data, and it returns us four things, which is x train, y train, and x test, y test. This load data function, it returns these four values. And let's also print the shape of these so these x train, y train, they are basically arrays. So what we want to do, we want to print the shape of these arrays. Oh, sorry. ytrain dot shape, similarly print xtest dot shape and ytest dot shape. So if we run this, to run the cell, either you can click on this run, or you can use shift plus enter. Okay, to execute a cell, use shift plus enter from your keyboard. So you can see that the shape of X train is 60,000. 60,000 means we have 60,000 images in our data, and each of the image is of size 28 cross 28. And corresponding to these 60,000 images, we have 60,000 labels by train. Similarly, in the test data, we have 10,000 images of size 28 comma 28, and the corresponding labels, right? So just let's try to take a look at the how the images looks like. So pld.im show, let's look at the the first image of our zeroth image of my, how it looks of my training data. So you can see it is of a 5. The first image in my training data, it is of a 5. Similarly, if I take a look, okay, how does the first, the second image looks like? It is of a 0. Then we have, let's say I want to say what is the, how does the 100th image looks like? So it is of, again, it looks like a 5, है ना? Half formed 5. Let's say you want to take a look at, maybe the, how does 5,000 image looks like? So it is of a 7, right? So this is how your images looks like. And what we want to do is we want to use this training data, this xtrain, to make uh, prediction, right? So let's create our model now. We have the data with us. Now we want to create the model. So to create the model, we have the knn model, and knn is equal to, we need to create an instance of it. So k neighbors classifier, and to train the model, the function is knn dot fit. So herein you need to provide your x train and your y train. So during the training phase, we need to show our model what are the like we collected these 20, right? In case of my pug, a German Shepherd classifier, we collected 20 data about 20 dogs, which was my X train and Y train, right? Similarly, here, my X train and Y train, we have 60,000 images instead of just 20, right? So we want to train the model. Oh, yeah. So the error it is giving is right now you can see that your training data, it has three axes, right? So it is kind of a 3D array, so we need to convert it into a 2D array. So the algorithm accepts 2D array size. So what we are going to do, we are going to flatten, you know right now corresponding to each image we have a 2D, right? Each image is represented using in a 2D array. So what we want to do, we want to flatten it into 1D. To So to do that, what we can do is we can use the reshape function, and so the number of rows, again, they are going to be 60,000, while the number of columns, what we are going to say, they are going to be 28 into 28, right? Yep. So now let's do that. So we are done with the fitting part, and now let's make classification or make prediction. Okay. So to make prediction, let's say I want to make prediction on Let's say my test sample is, let's also decide a I is equal to, let's say I want to see zeroth image of my test data. Right? And so to make prediction, you can use knn dot predict function. In predict function, while making prediction, you only need to provide the x, right? Only the features. So the features we have in test. So again, we need to reshape it because, or we do not need to. Let me see first. X test 0 dot shape. It is 28 comma 28. So remember that the shape of your array, it has to, so the rows should represent the sample and number of sample, and column should represent the number of features. So that's why we need to, reshape it. So number of sample is 1 and number of features, it is going to be 28 into 28, right? So yeah, I mean, just make the prediction and let's take a look. So you can see that, and let's also, that my model has spit a value which is 7, right? Now let's see whether this indeed belongs to, the image indeed belongs to 7 or not. So plt dot im show x test. I want to show the ith image of x test. I think that's it. Yeah, so you can see that yes, the ith image of my test, it is indeed a 7. Similarly, let's say if I change I to maybe, let's say, 8, I want to see how does the eighth image looks like. So let's make a prediction. So my model predicted that, the image spit a value 5. Now let's see whether the image is actually of 5 or not. So let's, so you can see that it is, yes, it is kind of 5 only. Let's say I want to test for maybe the 90th image. So let's make the prediction. It is saying it is of 3. So let's see if the 90th image is of 3 or not. So you can see it is a 3, right? So you can see that we have successfully, my model is correctly able to recognize these handwritten images. Okay. So that's it, guys, for this workshop. If you guys have any questions, then let me know. That would be it. And just a quick announcement that UPS Dehradun is organizing hackathon in the second week of February. So you guys should really participate in that, right? Because participating in hackathons is a good way to learn, right? So yeah. And also, we at Coding Blocks, there is this batch which is starting Java batch, so you can take a look at that also. From 28th January, we are starting a new Java batch, which will be taken by the mentor Monu Kumar. So you can check out the website, right? And yeah.
Okay. Thank you so much, ma'am, for your valuable words. That was truly something to be thought and acted upon. Well, it's true that every good thing must come to a good end. And now it's time for the sweet completion of this workshop, for which I, on behalf of the whole UPES-CSI family, would like to convey my sincere thanks to Miss Princey, who has been a great today and always. And thanks to the participants and the attendees who had been a truly amazing audience throughout the workshop.
Uh, Thank you,
With this,
Daksh.
I hope we will be meeting soon with another workshop, another day, but with much more enthusiasm and joy. Till then, stay home and stay safe. I, Dakshi Agarwal, on my part, sign off. Thank you so much. And also, we will be sharing an attendance form in the comment section so you guys can fill it for certificate purpose. And also, we will be sharing the link of the Hackathon 6.0 that is organized by UPS CSI. And you can guys go ahead for the registrations. Thank you so much, guys, for attending. Thank you so much. Thank you so much, ma'am.
Bye bye. Have a great day.